Bismillahirrahmanirrahim. In the previous video, we isolated DNA from our pure fungal culture. Now we want to know whether we have been successful in isolating the DNA or not, or DNA has been isolated or not. For this confirmation, we will run DNA on the gel. And the procedure which we are going to do today is agarose gel electrophoresis. Agarose gel electrophoresis is a laboratory procedure which is used to separate the biological molecules such as DNA or RNA with an electric current. And generally, by using this procedure, we can separate the molecules based upon the charge and based upon the size of the molecules. In this procedure, we will be needing agarose gel. For the preparation of the agarose gel, we will be needing 100 ml conical flask buffer, that is TBE buffer for the preparation of the gel, and a casting tray in which we will prepare the gel. We will weigh 0.6 gram of agarose gel. Agarose. This casting tray, it is a bit smaller as compared to the normal tray. So we will take it can be it has the capacity of 60 ml. You can see here 60 ml. So in 60 ml TBE buffer, we will add, after stirring it, we will weigh 0.6 gram. And we will add it and $60 ml. We will heat it in the microwave oven so that it can be homogenized. Agarose gel, it was heated in the microwave oven, and we have waited a little bit so that it may cool down. Now it is a bit transparent, you can observe it. Now we will add 2 microliter of ethidium bromide. It's a carcinogenic compound, so you have to be very, very careful while handling it. Now we will pour this agarose gel liquid into the casting tray, so when it cools, it may get solidified. In order to well place our DNA, our sample inside the gel, we will place a comb inside the liquid gel. So when it will be solidified, there will be wells or holes in it, and in these holes we will place our DNA samples. While it is getting solidified, the agarose gel, it is a gelatin-like structure, gelatin-like compound. It's gelatin in nature. So we can, upon heating, it becomes liquefy, and when it is cooled down, it becomes gel-like structure. So we can easily run our sample in it. Now, in this casting tray, it will be solidified, and after it gets solidified, we will place it inside the gel box. And here, this gel box, it is provided with electrode, that is positive and negative. When we will run the current through the supply, electric supply, and generally what voltage we give is 75 volts, and we place our sample in the holes which are made by this comb. Our gel has been solidified. Now we will transfer the gel into the gel tank. As the DNA is negatively charged, so we will, when we will place our sample inside these valves, it will move from the negative pole towards the positive pole. So the air is not a good conductor of electric current, so we will add a salt buffer, that is TBE buffer, through which the electric current can easily be travel. Now we will carefully remove the comb, leaving behind the wells. In order to load our sample and mix it with the loading die, we will place a piece of scotch tape on the top, and add 2 microliter loading die. Then we will add 8 microliter of DNA sample. and mix it. We'll take another sample. Now we will add this 10 microliter of our sample in the wells. In order to make our wells a bit clear, we will place some light over here. And then our next sample. Now we will add 6 microliter ladder in it. And we will dispense the ladder in the next well. Place the lid on it. And fix the positive and negative electrodes. The gel was run at 75 volts at 100 milliampere current and 50 watts power for 30 minutes. Because this casting tray is a bit smaller, so we will run it for 30 minutes. The 30 minutes have gone. Now we will turn it off. We'll remove the lids. And carefully we will pick it up. And we will observe this gel in the gel documentation system under the UV light. We will observe in the gel documentation system.